So we are presenting on the biomarkers of aging, and we have the multi-omics clock foundation. So first we want to think about what are biomarkers of aging, and really it's a bit obscure, but really we have molecular aging, and that's one type, which you can think of like AGEs, or you can think of alterations to the microbiome, the proteome, and these different molecular changes. And from there we have functional changes, so you can think of strength, you can think of ability to run fast. And then you have phenotypic changes, which really could be like visual, like physically looking old, wrinkles, and such. And so these are all biomarkers of aging that we're looking into. So this is essentially a heat map that we look at the Pearson correlation across several aging clocks. Of course, one's across the diagonals, and you can see the correlation between some of the clocks here. And really, we need to have a multi-omic approach. We need a combination of all these clocks to really determine a way to reverse the process. And that ties into, what is the most undervalued area? It really is, it's really laid out here. And you can think of, the relationships between biomarkers like we just saw on the last slide. So which ones are upstream, which ones are downstream? The theory would be that if you're having molecular changes to the proteome or these different interrelated systems, if you're having lipofuscin accumulation, there's going to be some relationships between those on the molecular level, which in turn are going to translate into functional changes, changes in your metabolism, and different changes in your gut bacteria, and then in the end, functional capability, sort of the main biomarker, one of the main ones that we really care about, the phenotypic age biomarker. Figuring out, mapping those biomarkers to disease pathways, this is critical. So if we have a therapy, the person starts at 50, then they age chronologically to 51, we can then look at a bunch of different aging clocks, say looking at like the epigenome, you can look at epigenetic clocks. Now, if you have one clock that says, okay, I've improved, but you have other clocks that says I have not improved, then there's definitely at that point there's a discrepancy between the clocks, and it's challenging to see which clock actually says that it'll have a good effect, as in no disease or increased performance. So that's one of the undervalued areas. Another one's going to be just having quantifiable endpoints. So if you have these endpoints, these epigenetic clocks or any type of clock, and you do a therapeutic, then you could then determine at that point if it's worked. If you can determine, of course, that clock relates to the disease state, which is one of the challenges. Another one, about single omics being potentially hackable. So this is sort of like if you take a therapeutic, or if you're a biohacker, you're taking, fisetin or anything, and then you look at one of your clocks, say like the glycan age clock, and then it's gone down. You think, okay, I've reversed my aging, but then in reality, the question is that actually going to have an effect? You can change the clock, but then is that going to make me stronger or have a different phenotypic change, essentially? And then undervalued because not enough cross-collaboration. So we really need collaboration across many organizations. I think this is definitely an issue. We see a lot of siloed areas where you have people collecting blood in one area on the globe and not necessarily sharing that data with other areas. So definitely it's a big issue. So where are we at today versus where we want to be? So we have, like I was saying, lots of small trials, and changing biomarkers have not been tied to outcomes. I was kind of just alluding to this, but when you see a change in a biomarker, can you then determine, is that going to be a positive? You're not going to get cancer, or you're not going to get diabetes. or you're going to be able to improve your capability, your performance, those kind of biomarkers. And this really just ties into what we need to do long term, which is all really just interrelated to increasing our physiology and being healthier. You know, if we can determine that optimizing one of these clocks that we actually truly are healthier, and we can isolate which clock that refers to, then we would see some benefits there. So what can we do? Collecting blood, biobanking that blood, really creating organizations that could then help us with that. So, you know, we need standardization across the different entities. You know, if it's not standardized, you're kind of just guessing. And I'm going to speed up a little bit, but we need to be able to measure as many clocks as possible across each study, and really getting these studies to be, you know, if you have a study that may not be an aging clock study, trying to convince those people who are running the study actually turn it into one at the same time. And lastly, last slide here, I know we're almost out of time, but these are some of the organizations that can help to fund it, potentially VitaDAO. And this is actually our what we want to do, a reverse aging biological age competition to have people come in, do a bunch of therapeutics, and kind of make it a competitive environment to see if they can win and reverse their biological age by a certain amount. For data sharing and biobanking, we have CureDAO for data sharing. You can look that up online. And Open Cures, which is right here in San Francisco. And lastly, sort of an open collaboration approach, you know, some kind of open summit to standardize these approaches. Thanks. Any questions?
Comments, questions?
Yeah, I'm definitely a pro-clock person, so we use clocks a lot and develop also. But for example, at the conference that next week is going to be Systems Biology Conference, half of the people are presenting the clocks. And most of them are kind of multi-omics, actually. I wouldn't call it the most undervalued. I think it's the least undervalued in a way, because it's so popular now. So it's happening by itself. But like we are struggling ourselves in terms of measuring what, because the clocks can be developed on many things, but we just don't understand what we are measuring, because we don't understand what aging is, what exactly going in that direction. This is the main challenge, causality, no?
Yeah, so I think undervalued in clinical trials. So a major point is that this would be measuring multiple clocks in clinical trials, so we'd be tying it to outcomes and to interventions, so drug trials. So if you could have every clinical trial that's going on that's either, you know, separately funded, a longevity study like a rapamycin trial or whatever, or, you know, even these disease trials, and you could bank some of the blood at the same time and run these clocks, all of them, not just one of them, then we could actually see which disease goes with which clock and which intervention changes which clock.
Just a question, disease or aging?
This is a philosophical question, right? I don't think they're different personally. But disease or aging, I mean, yeah.
I would say both. I mean, aging is the prime.
Clinical trials go for diseases.
Well,
No clinical trials for aging,
Well,
and
like
the
the one
clocks measure aging, but we don't know what aging is.
Well, so for example, the Biogen trial that just happened had a early use, right, with biomarkers, which was amyloid and CSF. So this would be similar, except we have clocks instead of amyloid and functional outcomes. Also, there are people running longevity trials, they're just not in the US, right? Yeah.
Just one word. I would not like to be on the airplane that is flying based on that treatment for Alzheimer's.
Totally agree. I mean, that's the problem with, that's why we need all of the clocks, and we need to tie it to functional outcomes like cognition. So that's kind of exactly the point, yeah.
So yeah, also a very pro-clock person. So we published, I think, maybe 20 clocks in peer-reviewed literature, and launched Deep Longevity, which integrates a bunch of clocks and apps and also supports a lot of clinics. So we have a few in the clinics. So currently there are a bunch of initiatives like that. One is XPRIZE, for example, right? So by Peter Diamandis, so they have a reversible biological age competition. I think they have it for a couple of years already, right? And it didn't go far. Nowadays, you can build a clock on pretty much anything that changes in time. So we even published the psychological aging clock recently, where you take a bunch of surveys and predict your psychological age. By the way, most popular clock that we've ever launched. 250,000 people immediately took it. And you can reverse it, because if you believe that you're going to live longer, you are actually going to be predicted younger. So right away, intervention. For anybody, very easy stuff to do. So my kind of question is that to bring this community together, there are many, many competing initiatives. Much of this research is done in companies. They're not going to share data openly. And there are already competitions. So if I were to do this, I would try to do several of those, and they would sit on top of biobanks, specifically on the UK Biobank. It's the best initiative to date, right? And a few national ones, because internationally you won't be able to share the data. So I would try to do national biobanking clock foundations. And they would collaborate, maybe do an aging clock association, not foundation. Just a comment.
Thanks for the comment. Wow, 250,000 people, that's a lot. Okay, wonderful. Thank you, guys.